Hello, in this video we're solving this problem. 3,185. A particle of mass m moves with negligible friction on a horizontal surface and is connected to a light spring fastened at O. At position A, the particle has the velocity VA equals 4 meters per second. That's actually speed, not velocity. Determine the velocity VB of the particle as it passes point B. Okay, so we have the spring, one end of it is pinned at fixed origin O, the other end of it is attached to the mass M, and the mass is moving in the horizontal plane with negligible friction. Interesting, we need to determine the velocity VB of the particle as it passes position B. Okay, let's think about this problem. If I draw the free body diagram of my particle, the only force acting on it in the plane is this spring force that is gonna be directed along the spring towards point O. Other than that, we have the weight and the normal force that are acting perpendicular to the page. And the weight and the normal force, they sum to 0, right? Because if I write F equals ma, the acceleration along EZ is equal to 0. So W plus M, which are both along EZ, should be equal to 0. Now, what's interesting is that this is actually a central force problem, right? Because the only force acting on the particle is directed toward the origin O. So if I calculate the sum of forces, the sum of moments acting about O, acting on the particle about O, which is R cross F, that's equal to R cross just the spring force. But the spring force is parallel to R, so that's just equal to 0. The sum of moments about O is equal to 0. So this is a central force problem. Very interesting. Okay, so the sum of moments about O is equal to 0. It's a central force problem. What does that mean? This means that the angular momentum of the ball about O, or of the mass m about O, is equal to 0. So the angular momentum of the system is conserved, namely the angular momentum of the system at TA or at state A is equal to the angular momentum at state B, TB or at state B. Okay, so again, R at A cross M VA is equal to R at B cross MVB. That's just what the angular momentum of a particle is. The moment of the linear momentum, R cross MV. Okay? So here A and B, they represent two different locations of the mass system at two different instances. So I'm using A to denote both the instance and the location. Okay, M and M cancel out. What about RA cross VA? Well, I know the magnitude of RA, I know the magnitude of VA, I know the angle they make between the two. So maybe let's just calculate the cross product using the definition of the cross product. That's equal to RA cross VA cross the absolute value of sine, the angle between them, 54 degrees. On the other side, we would get RB, which we know RB. Well, VB we do not know, that's what we need to find. And then sine of the angle between the two. Oh, that was a quick and easy problem because I already know RA. This is 0.35 meters. This is 4 meters per second. This is 0.23 meters. So, this is my only unknown. One equation, one unknown. I can solve for it.